In this video lesson, we are going to study esters. We will cover physical properties of esters. We will also go to giving examples of esters. We will go to hydrolysis of esters, and we will also discuss the commercial uses of esters. Before continuing with our topic today, please like this video and subscribe to our channel. Do not forget to hit the notification bell for more videos. What are esters? What are esters? As you know, esters are compounds that have general formula. They have a general formula of CN, H2N, O2. They have a general formula of CN, H2N, O2. And they also have a functional group of a functional group of they have a functional group of C, which can be represented as which can also be written as carbon, so that is how the functional group is. I said esters are compounds that have the general formula CnH2nO2 and a functional group of COO, or it can be written as in this form. It should be recalled that esters are derivatives. They are derivatives of carboxylic acids. Esters are derivatives of carboxylic acids. You know that in an ester, the hydrogen atom from the carboxylic acid group is replaced by an alkyl group. For instance, let's say this is a carboxylic acid. We said they are derivatives of carboxylic acid. This is the acid group. Or we can say this. And I said the hydrogen atom from the COOH group of the carboxylic group, of the carboxylic acid, is replaced by an alkyl group. And the alkyl group is usually provided by an alcohol. Here, the hydrogen atom attached to this carboxylic group, carboxylic acid group here, once it is substituted, this group is substituted by an alkyl group. When the alkyl group, let me say alkyl group from alcohol. Yeah, this group, the hydrogen, when once substituted by an alkyl group from an alcohol, it gives us an ester. So if the alkyl group is a methyl group, let's say a CH3, or an ethyl group, so in that case, we will start naming the ester as methyl something or ethyl something. As we go ahead, you will see what I really mean by it. So, in this case, it leads us to what we call esterification, the nitric acid and the alcohol. It leads us to what we call esterification. What is esterification? Esterification. What is really esterification? As you see, esterification is a reaction of a carboxylic acid. This is a reaction of a carboxylic acid or an acyl chloride or a carboxylic acid with an alcohol. A reaction of a carboxylic acid or acyl chloride with an alcohol or a phenol, to produce an esters, or to produce an ester and a small molecule of water or salt. I said esterification is a reaction. This is a reaction of a carboxylic acid, or with an alcohol. You are using an aromatic compound, a phenol or a phenol. Or a phenol to produce what? To produce an ester. To produce an ester and a small molecule. And a small molecule, usually water or salt. You were to use acyl chloride. So we are saying that esterification is a reaction of a carboxylic acid or an acyl chloride with an alcohol or a phenol to produce an ester and a small molecule. The small molecule is usually water or salt in the case of acyl chloride. It should also be recalled. That esters are dictated by their sweet and the fruity smell. They are dictated, esters are dictated, esters are detected. They are detected, from their from from their sweet and fruity smell. Esters are usually dictated from their sweet and fruity smell. And you should also remember that esters, the names of esters, the names of esters will usually end up in oate. Their names end up in oate. Their names end up in they end up in oate. That is oate. We can say ethyl ethanoate, propyl propanoate, or propyl methanoate, or propyl ethanoate. So their names end up in oate. Okay, let's see what, as we just said, they have a general formula of CnH2nO2 and a functional group of COORO. It can be represented in this form. I also said the carboxylic acid group, esters are formed when the hydrogen in the carboxylic acid group is replaced by an alkyl group. The alkyl group, when the hydrogen in the carboxylic group is replaced by an alkyl group, and the alkyl group is usually supplied by the alcohol. And now, the alkyl group could be a methyl group, it could be an ethyl group, and any other alkyl group that you might find. Then it drove us to esterification. And I said the term esterification implies that this is a reaction of a carboxylic acid or an acyl chloride with an alcohol or a phenol to produce an ester and a small molecule, which is usually water or salt. And I went further to say esters are dictated from their sweet and fruity smell, and their names usually end up in oate. Now, I want us to discuss a few things regarding the properties of esters. Esters, as you see, they have low melting and boiling point than carboxylic acid. Have low melting point and boiling point. They have low melting and boiling point than carboxylic acid. The reason is that carboxylic acids or alcohols can form hydrogen bonds, but esters cannot do. The fact that esters cannot form hydrogen bonds, it means that their boiling points are always low. They can't form hydrogen bonds. So they have a lower melting point and a boiling point than carboxylic acid. Boiling point than carboxylic acids, because they cannot form hydrogen bonds. They are insoluble in water. Another point is that they are not miscible with water. They are insoluble in water. They are insoluble in water because they cannot also form hydrogen bonds with water molecule. Insoluble in water. They are insoluble in water because they cannot form hydrogen bonds with water. They are insoluble in water because they can't form hydrogen bonds with water molecules. So since they cannot form intermolecular hydrogen bonds with water molecule, they are insoluble in water. Now, regarding the preparation of esters, how are esters produced? How are esters produced? Yes, we just discussed that esters they are produced by replacing the hydrogen in the carboxylic acid with an alkyl group, and the alkyl group is usually produced or provided by an alcohol. So we can now say they are produced by reacting alcohols with carboxylic acid or acyl chloride. They are produced they are produced by reacting alcohols with carboxylic acids. With carboxylic acids or acyl chlorides. So esters are produced by reacting alcohols with carboxylic acids or acyl chlorides. I want us to, these are some examples I want us to look at. Some of the examples I want to give here, I want to use propanoic acid and ethanoic acid. Propanoic acid and ethanol. Here we have CH3, CH2, plus the alcohol here will definitely be, let me use alcohol in a different color. Alcohol is, yeah. Okay, when a reaction like this occurs, what happens? There is, there is an equilibrium is established in this type of reaction. So let me use this here. And in that case, we are going to heat this alcohol and this propanoic acid and ethanol under reflux with concentrated sulfuric acid that is acting as a catalyst. Heating under reflux. We are heating under reflux with concentrated sulfuric acid as catalyst. So what happens here is that a compound is formed. And how is this compound formed? We said, see what is here. Yeah, of course, this is propanoic acid. This is ethanol. This ethanol. Now, when this happens, this is a molecule of water that is being removed. And now what will be our product? From this equilibrium that has been established here, our product will be what? Our product will be this will be our product. Our product here will be that will be our product plus water plus water plus water. And now remember in the naming we said in the naming, let me show you what is happening in the naming. This section from here, this is propanoid. This is ethyl, the ethyl group. This is the ethyl group. And now, what will be the name? What will now be the name of the compound that is formed? The name of the compound that is formed will be this. The name of the compound that is formed, it will now come from we said in naming, the first part of the name, which is the alkyl group, comes from the alcohol. Then the second part will now come from the acid, which is the wait. Okay, now the first part is ethyl. It comes from alcohol. We now say it is ethyl. Then the second part, which is propanoid, 1, 2, 3. There are 3 carbon atoms there. We'll now say it is ethyl propanoid. Propanoid. This is the name of the ester that is formed. This is the name of the ester. The ester is the ester now is ethyl propanoid. So, as we said, I said esters preparation, they are produced by reacting alcohols with carboxylic acids or acyl chlorides. An example is propanoic acid and ethanol. When they react using suitable reagent like concentrated sulfuric acid that is acting as a catalyst, it is heated under reflux, and the product produced will be ethyl propanoid. Ethyl propanoid. And I said in the naming, the first part of the name comes from the alcohol, and the first part of the name is usually an alkyl group that is given by the alcohol. Then the second part of the name comes but from the acid. From here, the first part is ethyl, and the second part is propanoid. Therefore, our ester form is ethyl propanoid, and a molecule of water that is also released. A small molecule of water that is also released. That is how esters are produced. Once more in the naming, I said the first part of the name, which is an alkyl group, be it a methyl group, be it an ethyl group, be it a propyl group or a butyl group, comes from the alcohol. And the second part of the name, which can be methanoate, ethanoate, propanoate, butanoate, comes from the carboxylic acid group, comes from the carboxylic acid. So there are 2 parts. The alcohol provides the first part, and the second part is provided by the carboxylic acid. This is an example of some alcohols, of some esters, sorry. An example of some esters here, you will see this ester here is produced from, the ester here is produced from an acid and an alcohol. The second part of it, the first part of it is in red, and the second part of it is in blue. And in that case, this red part of it is produced by an alcohol, is provided by an alcohol, and the alcohol that must have provided this is methanol. Then the second part of it is provided by the acid, and which acid is that? 1, 2, 3, 4 is butanoic acid. In that case, the first part of the name, the first part of the name, which is provided from the alcohol, is methyl. Then the second part is, since it is from a 4 carbon group, we call it butanoate. And we now say the name of the ester is methyl butanoate. The same thing goes with this one here. The red part of it is provided by the alcohol, and the alcohol is what? Is propanol. It's propanol. Then the second part of it is the acid, and is provided. Which acid is that? Is ethanoic acid. So it is now propyl ethanoate. The same thing goes to this other one here. the third one here. The first part is the alcohol here is ethanol. It has provided the ethyl group. The acid here is propanoic acid. It has provided the second part of the name. And the full name of the ester is ethyl propanoate. Finally, if we come here, we will see that the red part of it is provided by the alcohol, which is propa-1-ol, and the alkyl group is the propyl group, and the second part of it is provided by the acid, one carbon group acid, and the acid there is methanoic acid, and he has provided methanoate. So our name is alcohol, then acid. Alcohol, alcohol alkyl group, then the acid follows. Alcohol alkyl group, then the acid follows. Now we now say it is propyl methanoate. An example of it, or many other acid, or many other with this one, when methanoic acid react with methanol, our ester is methyl methanoate. And this is the structural formula, this is the displayed formula, and this is the molecular formula. They are all two carbon molecules. Now, when methanol reacts with ethanoic acid, we will have methyl ethanoate. This is the structural formula, this is the displayed formula, and this is the molecular formula of the ester. Now, when ethanol reacts with methanoic acid, we have ethyl methanoate. This is the structural formula, this is the displayed formula, and this is the molecular formula. When methanol reacts with propanoic acid, we will have methyl propanoate. This is the structural formula, displayed formula, and the molecular formula. And finally, when you have propan-1-ol reacting with a methanoic acid, the ester form would be propyl methanoate, and this is the structural formula, this is the displayed formula, and this is the molecular formula. So learners, if you go through this several times, understand it, it will be easy for you to understand esters. Our last section, prior to our last section of this lesson today, we will be dealing with hydrolysis of esters. Hydrolysis of esters. Now, regarding hydrolysis of esters, esters can be hydrolyzed by heating under reflux with either a dilute sulfuric acid or aqueous sodium hydroxide. You can hydrolyze esters in acidic condition or alkaline condition. Under acidic condition or acid hydrolysis, you are going to use dilute sulfuric acid. But if you are going to use alkaline hydrolysis, you are going to use aqueous sodium hydroxide. Let's start away with acid hydrolysis of ester. If you take an ester like this one, ester like this is let me see, ethyl ethanoate. We will have H3 ethyl ethanoate. You are hydrolyzing it now using acid hydrolysis. In that acid hydrolysis, we are using dilute sulfuric acid. Dilute sulfuric acid using dilute sulfuric acid. Hydrolysis. The product, if you hydrolyze it using acid hydrolysis, we are going to have our product will be ethanoic acid and ethanol. It's a reversible reaction. That is why you see it like that. H3. We will have this and plus what? Ethanol. So internally we are saying that with acid hydrolysis, I say one is acid hydrolysis. With acid hydrolysis, this is ethyl ethanoate. Ethyl ethanoate undergo acid hydrolysis, which is a reversible reaction and equilibrium is established. We will have ethanoic acid and we will also have ethanol. So we are indirectly saying that with acid hydrolysis of ester, acid hydrolysis of ester will result in a reversible reaction. It will result in a reversible reaction where an ester equilibrium is established. We will go back to the original reactants when under acid hydrolysis of esters. We will go back to ethanoic acid and ethanol that were used in the formation of the ethyl ethanoate. On the other hand, if we want to go to alkaline hydrolysis, with alkaline hydrolysis, with alkaline hydrolysis, with alkaline hydrolysis, the reaction is not reversible. With alkaline hydrolysis, the reaction is not reversible. This reaction is not reversible. So, what is formed? We will still have H3, alkaline hydrolysis, as I said, alkaline hydrolysis with sodium, aqueous sodium hydroxide. With aqueous sodium hydroxide, the reaction is not reversible. Here we have aqueous aqueous sodium hydroxide, that is OH, and this is hydrolysis. The product form in this alkaline hydrolysis, would be a salt of the corresponding carboxylic acid, which will be the product form will be so we have sodium ethanoate, and ethanol that is formed. That is a product of the hydrolysis. So once more, we said esters can be hydrolyzed by heating under reflux with either dilute acid or aqueous sodium hydroxide. And if we are going to do the hydrolysis under acidic condition, acid hydrolysis result in a reversible reaction and equilibrium is established. But with alkaline hydrolysis, there is no reversible reaction. A salt of the corresponding carboxylic acid is formed, a sodium salt of corresponding carboxylic acid is formed, and the alcohol. So with acid hydrolysis, we will have, it is a reversible reaction. We will have ethanoic acid and ethanol that will be formed. This is an equilibrium that is established. But if the hydrolysis was carried out under alkaline condition, alkaline hydrolysis, using aqueous sodium hydroxide, there is no reversible reaction here. The result will be a sodium salt of the carboxylic acid, that is sodium ethanoate and ethanol. And this carboxylic acid, as I said, was ethyl ethanoate. Ethyl ethanoate was ethyl ethanoate. So that is how it is. Finally, esters, because of their fruit, because of their sweet, fruity smell, ester have many commercial uses because of the nature of the flavor that comes from there, from the product. It is now used as a commercial product in many ways. So some of the uses of esters will include, number one, I will say they will act as solvent, as solvent, as solvents. When I say esters, one of their uses is, they will be used as solvent is, I'm saying that small esters such as methyl ethanoate, ethyl ethanoate, butyl ethanoate are very widely used as solvents. They are widely used nowadays as solvents. Some as detergents, because of the nice smell that comes from there. They are also used as detergents. The second one will be, they can be used as perfume and flavorings. As perfume, as perfume, as perfumes and flavorings. We said they can be used as solvents. Secondly, they are used as perfumes and flavorings. And as perfume, as I said, because of their sweet, fruity smell, esters are used in food industries to improve the flavor in foods and in drinks. For instance, the flavor there you will see are from products of esters. These are esters that they use in giving the flavor in ice cream and other food products, and even in many drinks. In drink producing companies, in food producing companies, they are used as flavor to improve the flavor in the food and and drinks, to improve the flavor in foods and drinks. And number two, esters, esters such as I say, as perfume. Perfume industries will use to manufacture many perfume using esters. An example of it is benzyl ethanoate. Benzyl ethanoate for perfume industries. Perfume industries. I said benzyl ethanoate benzyl ethanoate or what we call the gardenium. Gardenia fragrances. Gardenia fragrances are used to produce jasmine. to produce jasmine or gardenia fragrances. And lastly, they are also used in flower industries. Flower industries. They are also used in flower industries. In flower industries, especially flowers with naturally occurring esters. In flower industries, they are also used there, especially flowers with naturally occurring esters. These flowers are used in producing other flowers that have flavor, other things like that. So, learners, these are some of the uses of esters. I said they are used as solvents. They are also used as perfumes and flavorings in industries such as the food and drink industries. They help to improve flavor in food and drinks. I give example of ice cream and other fruit juice that you drink. They are also used for perfume industry. I give an example of benzyl ethanoate or gardenia fragrances that are used to produce jasmine or gardenia fragrances. And finally, they are also used in flower industries, especially naturally occurring, flowers that have naturally occurring esters. Thank you very much. Please, if you haven't subscribed to our channel, please subscribe and hit the notification bell. Thank you very much for watching.